Good morning, everyone. We have started chapter 6, number 6, and we are into solving what we call a scalar field problem. Okay. Yeah, and yesterday we derived for 2D heat conduction problem. Yeah, and we derived for isotropic conductivity. This is the divergence of k times gradient of t plus sx is equal to 0. Yeah, so this is the equation that we derived. And now we want to solve it. Yeah. Okay, now it's not s just, okay, so it should be is equal to 0. So this will be a function of x and y both. Yeah, so it can vary. Yeah, so yesterday probably I must have written just x, but it should be a function of both x and y. So this is about 2D heat conduction. Okay, and finally for simple case, when x s x y equal to 0, what it becomes is and k equal to constant, what we get here is simply gradient, the divergence of gradient of t is equal to 0, or simply this also we know as is del square t is equal to 0, where del square means del square over del x square plus del square over del y square. Yeah, so this del square t over del x square plus del square t over del y square equal to 0, or del square t is equal to 0, what we know them as Laplace equation. Yeah. Now we want to solve these problems. So this if you have this problem, Laplace equation, if you want to solve, you must have done in your differential equation course already. Remember that till the chapter uh, 3, 4, 5, we dealt with ordinary differential equation, right? Why ordinary? Because we had only one variable, so it was 1t. So only x was the independent variable. Yeah. So they are partial or absolute, both are same only. But in 2D, that really means 2D and 3D means chapter, when you have chapter 3, 6, 7, 8, we are talking about even 9, we are talking about where we will have this partial derivative. Yeah, so this is partial PDF, partial differential equation. As such, finite element analysis is basically solution of partial differential equations. Yeah. Okay, so this uh, the original equation we want to solve del square t over del x square plus del square t del y square equal to 0. So before we find out the approximate solution, we also have to know how to find out the exact solution. So if you can find out exact solution, why to go for uh, the approximate solution? Okay, as I said earlier, approximate solution is for when you cannot solve it analytically, then only you do it, otherwise there is no use. Yeah, so in any case we have to know this one. So if you want to solve this, let us say again, whenever equation is given, there has to be some boundary condition given. So let us say it is something like this. Boundary condition, it can have say you have x direction this and y. Yeah, so let's say at x, rather t at, this is x equal to 0, x equal to 0, this is x equal to a, okay, this is y equal to 0, this is y equal to b. Okay, so let's say t at x equal to 0, and y can vary, means here the t is 0 only. So at this one t equal to 0. Here also let's say t equal to 0. So that means t, right, at a, y is also equal to 0. Yeah, so here also 0, the whole thing is 0. Here also let us say t equal to 0. So I'm making it very simple actually. So t equal to 0. So t and then x, so all x, and y is equal to 0, is equal to 0. And let us say this point, so t at x, yeah, t at x, and y is b, is equal to, let us say the value is x square. You can have that anything, right? So let us say this is x square. Okay, so we want to solve it. Then let us see what happens. Okay, now how to approach. Yeah, so that we want to discuss. Again, you may be knowing already, but still we want to do it. This is may not be in your book, but still I want to do it. Just maybe the repetition, but you should understand that how to solve, or you can, at least it will be a revision for you guys. So what we use is separation of variable. Yeah, so this is because you already have this study. That's why in book it doesn't give you, but you can always refer to your mathematics book or notes. Separation of variables, in which you assume that txy is nothing but has a two function, capital X which is a function of x, and capital Y which is a function of y. So this is the combination of two variables like this, or two functions. Yeah, so x and y. Okay, or okay, let it be like that. Now, what happens if you put that in the original equation? Then we get del square x y over del x square plus del square xy del y square equal to 0. Or remember, this is a not function of x, so y will be outside. Del square x del x square plus x del square y over del y square is equal to 0. Yeah. Now divide them by xy. So what you will get? You will get 1 over x. 1 over x del square x over del x square plus 1 over y del square y over del y square. Right? So this is a capital Y. Okay, is equal to 0. So what we did? Divide by xy. Yeah. Okay. Now what will you do? Here we will assume that the 1 over like 1 over x del square x del x square is equal to what we get, minus 1 over y del square capital Y del y square. Yeah, so this is how you find out. Let us say this is equal to, this is equal to alpha. Yeah, or we just write it equal to minus alpha. I tell you why minus alpha. But it doesn't matter actually. In any case, it doesn't matter. But I'm writing minus alpha. Why? Because of solution. You know. So but either way is fine. Let's put alpha only. Okay. So where we don't know alpha nature of the alpha, alpha can be a positive or negative number. So alpha is either positive number, right, or a negative number, depending on we get the solution. Let's say alpha is a positive number, right? So this alpha like this. Then what happens? Then our equation del square x 1 over x, right? Del x square, right, equal to minus 1 over y del square y del y square is equal to alpha. Now we are saying that this alpha is positive. Then we have two equations. First equation, we get del square x del x square minus alpha x equal to 0, right? So this equal to this, if you put, then x goes here and then it comes back here. So we have this equation like this. And number two equation is del square y over del x square plus alpha y is equal to 0. So you see here, this is because of minus, we get plus here because of plus here, right? Both of them, you get minus here. So both of them will have different equations. Okay. Now you have to see the solution.
So it's
now
del square y upon del y square in second equation.
Say again.
So in the second equation, it will be del square y upon del y square.
Yeah, sure. Thanks. Yeah. Okay. So we have that. Now what we see, we are used to this. We know the solution of this because this is 1D now, right? So what we see here is you can treat it as like absolute, because this x is function of x only. So then total differential, basically, you can assume it, right? So, and you can solve it. Now, what is the solution? If you have alpha is positive, remember that, then what is the solution? The solution is, you can solve like this, like what you do, you can say d square minus alpha x equal to 0, right? And d equal to plus minus root alpha. Yeah. And in this case, what do you get? D square plus alpha y equal to is equal to 0. Okay, y equal to 0. Sorry, equal to 0. So here d is equal to plus minus of that, right? Plus minus I root alpha, right? So what you get here is since alpha is a positive number, your solution from 1 you get x values, right? X will be equal to c1 e to the power, see here, yeah, minus root alpha x, right, plus c2 e to minus plus root alpha x. You can write like this one, as also we saw yesterday, or you can also write, like x equal to c3, let us say, a sine hyperbolic, right, root alpha x plus c4 cos hyperbolic root alpha x. Yeah. So this is better to write this one because it's easy, so finally it will this will also come in the same form only. So either you can write this or this. Yeah, this is you can use that. So number 1 is like this. From number 2, what do we get? We get plus minus, right? So we get x equal to y equal to c5 e to the power minus I root alpha x plus c6 e to the power I root alpha x. Yeah.
So it will be y root alpha.
Yes. Correct. Yeah, it will be y here, and similarly you can also write, since e to the power I is nothing but you can also write in sine and cosine terms, so we can write is equal to because everything, the input, the values are real numbers, so you can also write finally it comes down to sine and cosine only, the imaginary term will not be there, and you can write C7 sine root alpha y plus C8 cos root alpha y. Yeah. So either you can write like this one or this one, but you can relate here. Here in this case, since alpha is positive number, so there will be exponential term only. Here imaginary term, so you will have the sinusoidal term only. So we will choose these two values because this is easy to work with. This, okay. Okay, now what we see, now you have to apply the boundary condition. If you say apply the boundary condition, then what happens? You have to know from 1 we have to apply, right? So x, we know that t, right? So the values are t here. Yeah. So this one, t0 y equal to 0 and t a y equal to 0. Right? This is a. Okay, so this is a. So those both has to be 0. So now we have to see whether boundary condition will can be satisfied here or not. So t0 y is equal to 0 and t a y equal to 0. Now let's put it here, say in xy, in both the cases. What do we get? When you put 0 here, in this case, if you get 0 here, then what happens? Yeah, means x0 and y has to equal to 0, right? That tells you what? So this is nothing but this, x0 and y equal to 0. So that means, that tells us that x0 has to be equal to 0. Similarly, this says t x a multiplied by y is equal to 0. That tells us that x a is also equal to 0. Okay, so that means what? x0 equal to 0, x a equal to 0. That means simply that C3 x0 equal to 0. That means C3 sine h, okay, sine h0 plus C4 cos h 0 equal to 0. Sine, hyperbolic sine at 0 is 0. So C3 will be, this term will be 0, but this here, this will be CH0 equal to 1, right? We have 1. Because why? Because you know that cos h equal to ex plus e to the minus x divided by 2. Yeah, and then if you put 0 here, then becomes 1 plus 1 divided by 2 is equal to 1. And sine hyperbolic is equal to e to power x minus e to the minus x. Right? So this will be at x equal to 0. This is of x. Okay. So that really means, tells you that C4 is equal to 0. So this gives C4 equal to 0. Yeah. Now second equation. Second equation is x at a is equal to 0. Right? Okay. Tells us what? C3 sine h root alpha a is equal to 0. Yes. Okay, now the thing is, can it be 0? Hyperbolic sine is 0 only when hyperbolic sine is 0 only where? Only at 0 only. There's no place it will be 0 again, right? Hyperbolic sine, if you calculate, this will be look like this. This is x, right? And this is the sine h. Yeah. So it will be 0. So it will go like something like this, and then it will be like this. Yeah. So it will be 0 just here. There's no other place it can be 0. So that really means what? It's only possible when you have alpha equal to 0 or C3 equal to 0. If alpha is not equal to 0, C3 has to be equal to 0. So that tells you that C3 has to be equal to 0. There is no other way. If alpha is a positive number, either alpha has to be equal to 0 or C3 has to be equal to 0. But we are finding out C3, so this will be equal to 0. That really means that it tells you that x has to be equal to 0, and then t x y equal to x times y is simply equal to 0. So it's a trivial solution. It's not good. Yeah. So that's the problem with this, with assuming alpha to be a positive number. Yeah. So that's why we have to make alpha as a negative number. So we assume now that the other way around, so that we get non-trivial solution. So t equal to 0 is a solution of that. Anyway, so you can, if put t equal to 0, it will give you 0, right? So that's a trivial solution. So what we will do, alpha less than 0 we'll assume now. Yeah, alpha less than 0. If we assume, then we will see, let us say alpha less than 0, let's alpha equal to minus beta square. Yeah, let's assume that. Now our equation becomes del s square x over del x square 1 over x is equal to minus 1 over y del square y over del y square is equal to minus beta square. Yeah. And now we can see that it can be satisfied. Yeah, the sinusoidal, it can have 0 at 2 places, right? So our first equation now becomes, let's call the third, because 1, 2 we have used already. So what we have, del square x del x square plus beta square x equal to 0, right? And then fourth equation becomes del square y del y square minus beta square y, sorry, capital Y is equal to 0. Yeah. Okay. So what solution we get? We already, since this is a plus, so this will be plus minus. So from 3 will give you y equal to, we already have, right? So y is equal to, we get, let's write is values as 1, 2, 3, 4, C8 already we have used. So let's say C9. Okay, C9. Okay, sine beta x plus C10 cos beta x. Why? Because here this d square plus beta square, right, x equal to 0 and d is equal to plus minus I beta. So e to the power this means sine and cosine term will be there. So that's why we have sine and cosine terms. So y equal to this. Sorry, this will be x, not y, but this will be the x, like this. Yeah. And number 4, we get y is equal to C11. Just a minute, guys, some urgent call. Just a minute. Okay, sorry, guys. So y equal to C11, and then we will have sine hyperbolic beta x plus C12 cos hyperbolic, sorry, beta y. Yeah. So this will be exchanged now. Earlier this was hyperbolic, now it becomes sinusoidal, and this becomes now hyperbolic. So like this. Yeah. So this is the solution. Now again we can have t as we did earlier, t0 y is equal to x0 y is equal to 0, and hence x0 equal to 0, right? So that means you can put that value here. So that tells you that C10, just a minute, guys, just a minute. Okay, so C10, we have x0 is 0, so C10 has to be equal to 0. Now next is T A y is equal to x a y equal to 0, right? And then what we get? We get x a equal to 0, right? So x a equal to 0. Hold on, guys. Sorry, guys, some urgent calls that we got from the director office, so I have to attend. So this XA, when you say that really means we put those value here. So what we get, C9 sine beta A, right? Plus C10 is 0 anyway, so that's this value, and that equal to 0. Yeah. So now this is equal to 0. That really means what? Here C9, either C9 is equal to 0 or these things has to be equal to 0, right? So that means any value you put here, any value, that will be okay, as long as you have like this, if this becomes 0, right? So but if you make C9 equal to 0, then it's a trivial, right? So we want non-trivial solution. So then we can say non-trivial solution. So C9 not equal to 0. We'll put that. So in that case, sine beta alpha beta A is equal to 0. Yeah, and that will happen only when beta A is equal to n, a value n pi, right? So where n is equal to 0, 1, 2, 3, or plus minus. You can also have 0, plus minus 1, plus minus 2, and so on, right? Okay, so it has that means your solution in that case becomes equal to x is equal to, there will be a lot of solution in this case, right? So we can have in fact a combination of these. So you can have this equal to a summation where you have n is equal to minus infinity to infinity, basically you can have, right? So all negative, or you can just have the positive number as well, you know. So typically you don't write this way, you write n equal to 0 to infinity, and then you have some coefficient, right? So so this coefficient we can write as C we have used, so we will not use that. So let's say gamma, that's right. So this gamma I, which is a coefficient, or okay, that's fine. And then we have the sine n pi, right? Or this is n basically. So okay, gamma n. So gamma n is a coefficient constant. We have to find out that, and this is summation of that will be the solution as far as this is concerned. Yeah, this is a series solution. The Fourier series, basically the concept you have to bring it, and in order to find out this one, you have to do the Fourier series analysis based on all. So all those things are, it goes into that. But general solution we found out this way. Now the next thing is finding out the other equation, and what equation we had the boundary condition for the other one. So here this one, right? Now we have y at x0 equal to 0. Yeah, and that means we had this as a solution, C11 this. If you put y equal to 0 here, so then this term C11 term will disappear because this is equal to 0. Only you have C12. So C12 becomes equal to 0 because this value becomes 1 if you put y equal to 0. So that really tells you that C12 equal to 0. Yeah, so that means sorry, this is correct. Okay, so that means no, this will be t like this. Yeah, okay, is 0. That means this means y 0 is equal to 0, and that means this. Okay. So that really means y is equal to y equal to CL11 and sine hyperbolic alpha y. sorry, beta y. This is the solution for y, right? Yeah, so now and the other end you have here. Here, so what do we have? We have y we have t at 0, sorry, x, t at x at and 0, t at x and y equal to b. Yeah, y equal to b is equal to, we have some boundary condition, we say this is a function of x, right? We said it was equal to x square, right? Okay, so this is the equation, right? We have a txb equal to x square. That's where x varies, where x, you know that this x varies from 0 to a. So this is how it is. So if you put that really means what? This one is nothing but, so nothing but you have x, and then you have yb is equal to x square. Yeah, where yb equal to this, so you have x multiplied by yb is equal to c11 sine h beta b is x square, right? Okay, so then what do you have? You have the c11, yeah, c11 x of x is equal to x square okay, just a minute, c11, then x of x is here, and then sine h, just write it all completely. So we do have x value, so that is known now, and here just we want to use it basically. So we have x value which is known, so c11 will be equal to simply x square divided by xx, and then divided by sine h beta b, right? So this is what the c11 value will be, right? X square divided by this and divided by this. Yeah. Okay, so finally what value do we get? We can get c11 anyway is a function. It can be a function of x, but so what we get is a function of x only. So yy, so yy will be equal to these complete things, x square. So we get x square over x, right? And then 1 over sine beta b. 1 over sine beta b. We get like that. So that means x times y, xy is equal to, becomes what? So simply what we get is txy tx y is equal to txy equal to xx, yy is equal to xx, and y's value is x square, right? Sorry, our, yeah, sorry guys, this one is just C1, right? Just a minute. So this one is just C1, right? This one is x square C11 only. This is C11 only multiplied by, we should have sine hyperbolic, sine, it should be hyperbolic here. Yes, this should be sine hyperbolic beta y. Yeah, this is y. So this equal to xy, then y this one. So we have xy multiplied by this one. So we have x square divided by xx sine h beta b, right? And then you have sine h beta y. So these will cancel out. So finally we have t xy is equal to x square over, yeah, is equal to x square over, and then we have sine hyperbolic beta b and sine beta y. Yeah. It's fine, guys. However, this it's okay. Any question, guys? Any question here? So our, just a minute. That's okay. So this is how you get the solution, yeah. And if you put this, we can check it also whether it is working fine or not, basically in that. And let us see if you get we have applied this one, whether we can get this solution or not. So we can put that back and let us see. Okay, so in case of any problem, it will be there. So what we get if we claiming that our solution is this x square over this, so then it should solve, and it will have the same boundary condition. So first del square t over del x square over del square t del y square has to be equal to 0. So let's check. Whenever there is a problem, you can always check it. So what we get here is del square t over del x square. So we put here del over del x square, and we can have x square over sine, so x square over sine h beta b, sine h beta b multiplied by sine beta y, sine h beta y, and similarly del square del y square, and x square sine h beta b sine h beta 1. Okay, so see if it can solve. So we have from here we get from first one, what we get is equal to, so sine beta y over sine h beta b sine h. Yeah, and then you have x square, so this becomes 2, right? It's 2, right? Okay, and then plus we get x square, and then sine h beta y, so we get beta square as beta square sine h only, so x square, and then we get beta square sine h beta y, double differential, we get sine h beta y, like that, right? You guys agree? So we put the 0 value here. Yeah, first x equal to 0. Okay, is this 0 always? Sine y x square square. Okay, guys, there's something wrong. Okay, just hold on. So this is x square. We get x y x square x to y equal to beta c1, and that we want to be. So y beta is c1 sine. Oh no, okay. So c11 we get sine h beta x square. Okay. Where h, this also have to vanish, right? So x square terms sine beta is correct. So we have like that dot x y x square above x is plus y equal to this. So x so 0 automatically, but Okay, guys, there is somewhere, okay, we made mistake. Okay, okay, so I will continue from here tomorrow. Okay, so we also find out. So there should be some steps that was not correct. So I'm not able to figure out where. Okay, so we will carry on from here tomorrow. Okay, see you tomorrow. Question, otherwise. Okay, see you tomorrow, guys.